This is the 5th video and a chapter on essential ideas of chemistry. We're going to talk about the subtopic accuracy versus precision, by which we mean the uncertainty. So we said that the three parts of a measurement are the number, the unit, and the uncertainty. This video is going to be about the uncertainty part of a measurement. So when we make a series of measurements, we can measure how good they are by indicating whether they are accurate or precise. We hope they'll be accurate and precise. Of course, we always hope for the best data. But unfortunately, it's not always true. So accuracy and precise measured as, or accurate and precise measured as accuracy and precision. Okay, so if your measurement is accurate, that means that it's close to the true value. So if you know the mass of a certain object should be 67 and your measurement is 64, you could say that that measurement is moderately accurate. If something is precise, that means that it is close to the other values in the set. So technically, precision is only for several measurements. You're trying to say whether those measurements are all close together. So I've got an example written here for baseballs, so we can practice identifying if something is accurate or precise. And I was going to use green for that, so we're going to put a green underline under it. Okay. So a standard baseball has a mass between 5 and 5.25 ounces, according to Google, which I wholeheartedly trust. So let's look at the accuracy and the precision of these 3 bags of baseballs, knowing how much a baseball should have a mass of. Okay, so in this first bag of baseballs, we've got 6.13, 5.99, and 6.02 ounces for the 3 balls. And so for accuracy, we know that the numbers should be between 5 and 5.25, and none of those numbers are in that range. So I'm going to say this data set is not accurate. Let's look at the next set. So the second bag has 4.50, 5.50, and 5.00 ounce baseballs. And the ideal mass is between 5 and 5.25. So one of those numbers is in the range and the other numbers are close. I'm going to call that semi-accurate because it's still not awesome, but it's better than the last one. And in our third bag of baseballs, we've got a 5.12, 5.27, and 5.14 ounce baseballs. And the mass we're looking for is between 5 and 5.25 ounces. And 2 of those numbers are within the range, and the third one is close, very close. So we're going to call this an accurate bag of balls. Okay, let's look at the precision. So precision is about how close the values are together. So in the first set, all of these numbers are within 0.2 of each other, so those are very close together. So those are precise. In the second set, they're off by about 0.5 from each other, so I'm going to say not precise. And for this set, again, all of the numbers are within 0.2 of each other. This one is precise. So let's review the bags as a whole. So the first bag, the baseball masses are precise. They're all close together, but not accurate. They're not within the standard baseball mass that they're supposed to be. In the second bag, it is accurate, but not precise. So the numbers are loosely closer to the correct number, but they're not close to each other. And the third bag is accurate and precise. The numbers are close or within the range that they're supposed to be, and they're close to each other. So the third bag of baseballs would make the best data set. We don't always get that lucky, but sometimes we do. Okay, so we've talked about precision. The precision is how close to how close together the numbers are. This is also a measure of the uncertainty of a number. So we indicate the precision or uncertainty of a measurement using significant figures. We will talk about those more in the next video, but basically those are just how many digits are included. So each of these have about 3 digits included. That's about how sure we are of the certainty of that number. And the last digit that's reported is uncertain. So in these numbers, in 6.02, the 2 is the last number that's reported. So that is the number that we are uncertain about. So let me give you an example. Let's say we measured a few more baseballs. One way we could express the measure of the baseball, including the uncertainty, would be to write it like this. Mass of a baseball is 5 plus or minus 0.1 ounces. And so this is a measurement, and we can see the 3 parts of the measurement here. So this part, the 5.0, that's our number. The plus or minus 0.1 is our uncertainty. That tells us about the precision of this number. And then the ounces at the end, that's our unit. So this is telling us about how certain we are that 5.0 is an accurate representation of the average mass of a baseball. So if it's 5.0 plus or minus 0.1, we know that the true value is between 4.9 and 5.1 ounces. So we're going to say this number is not very precise because there's only 2 digits in the number, the ones place and the tens place. So this is not even as accurate as your bathroom scale, which at least has 3 or 4 digits in it. So let's try measuring the baseballs again. Let's say that we had a different scale and this scale was more accurate. And so it measured it as 5.000 plus or minus 0.001 ounces for that bag of baseballs. On this scale, we can say that the true value of the baseballs is between 4.999 and 5.001 ounces. So this one is very precise compared to the last one, because this one has 4 digits included in the answer, and the 4th digit is the one we're uncertain about. So when we report a number, we only want to report the digits that we are certain about, and the last digit that we report is the one we're most uncertain about. So in the next video, we will talk about significant figures even more in depth and how to know if a number is significant and if a particular digit is significant.